The four of us a few weeks ago participated in a first Go hackathon, and our application for encoding video made it to finals. That was unexpected and cool. What shall we talk about? I will tell you what Go is, why it's hot. We shall look at some code, and I will tell you where to start, and questions and conclusion at the end. So, what is it? It's concurrent language. It is compiled. It compiles really fast. You get cross compilation for various platforms out of the box, so you can compile for Windows on Linux, etc. It's general purpose language, but it was designed with system programming in mind, and it's visible through the language. It's statically typed. It's garbage collected. It's memory safe. It has explicit support for concurrent programming. And language is small in any way you look at it. It has small grammar and it's easy to learn. Three seasoned experienced developers made it, and from them the things they did, it borrows certain features. From Unix, it borrows pipe mechanism and atomic single-purpose programs. It's very fast. It works great with UTF-8 and has excellent concurrency support. Go is opinionated language. Opinionated in a way that it has preconceived ideas about what programming language should have, and more importantly should not have, in order to make programming easier and more practical. You will like it or you will hate it. There is no middle ground with Go. It doesn't have all of these language features. And some are very basic. For example, it doesn't have default function parameters. So why wouldn't it have default function parameters? Well, when you open somebody else's code or your code in a year, and you look at a calling of some function, you see everything that function has. There is no hidden parameter. See? Some other features were not put in language because the team wouldn't have to compromise speed. That is the case with generic programming. They like the feature, but they didn't make a proper way to implement it in a language. And maybe in version 2 or version 3 it will come. It does have some other features that compensate for the lack of the list in the previous slide. It has type embedding, where you can embed one type methods in another. So with this you get kinda like inheritance, but it's not. It has panic and recovery and multiple return values, and with this it can compensate for exceptions in a way. It has an empty interface, it's a sort of a base class in a language, and code generations, and these two features can compensate in most cases for generics. It is opinionated, but it's not dogmatic. It has lots of object-oriented elements. Types have methods, they have local state, they have behavior, they have private, public access. But it also has lots of functional elements. First-class functions, higher-order functions, user-defined function types, functional literals, and closures. So, why it's hot? Well, it has the most fearsome mascot in the world. This is Gopher, a Go mascot. It has big eyes. It's very fearsome. It's easy to pick up. Syntax is C-based. And this is a small example of syntax. Do you see it in the back row? Okay. So we declare a package main. We import two packages. Then in the function main, we declare and initialize two two variables with strings. And although this language is statically typed, we didn't declare these strings to be these variables to be strings. They are derived from what's on the left side of this operator. Okay? Then we open a connection to the database and expect two return values. The second value is an error, and if an error occurred, we will exit the program with an error. Then, if the opening of the database was successful, we defer the closure of the connection with the database. This keyword defer will execute the function, and when this main function exits in any way. And it's a very useful feature. So, what if we don't have DB package from the last slide? Well, we can just type in command line go get an URL of that package. Go has some great command line tools that come with the compiler. You have go build for building application. You get a go for formatting your code. You get Go test. Go has a built-in unit testing framework and benchmarking tool. You have Go tool proof, which is a profiling tool. It will profile your application for CPU and memory usage of every function, and it can output a PDF file of the tree of execution with times and memory usage of every function in your program. So you can optimize it very good. The list goes on. Okay, let's look at the code. First, I mentioned that Go has this notion of pipes. Not in the language syntax as much as in the language, the way the applications are written. And I mean it in a Unix shell pipes. I hope everybody used them in some point their careers. Okay, let's look at this code that has three segments. This is picked up from the real application, and I just removed rest of the application. So in the first block, we declare this, we initialize static handler, and static handler, HTTP handler, will serve static content, images, CSS file, JavaScript, etc. And he does not have zip capabilities. Okay. So in order to upgrade him to have zip capabilities, we wrap it in a zip handler. And then we, this composite of two handlers, we hook up to all URLs that begin with /research. You get it? The second example is similar. We have an update handler, and in our application this update operation is sensitive and only authorized user can access it. So in order not to pollute the update handler with the authentication check, we wrap this handler in auth handler, and it will check the credential for us. Then we hook this composed handler then on update /update URL and only on post, for example. And this pipes mechanism can be combined. So I can, for example, I can hook an authorized handler to the static handler and have a static content that will be checked for authentication. Or I can hook zip handler to the update handler and everything. And if client understands zip, it will be sent in zip format. Then, at the end of our main function, we will start the server. Go applications, in difference to PHP, are servers. Your application will start and it will run indefinitely. And this line will start the server on port 8080, and it will serve all these handlers that you hooked up previously on it. The second, the first feature actually in the language is concurrency. Concurrency is a big topic in Go. It's what made language famous, and one of the reasons it was made. In Go, concurrency models is based on Go routines. Go routines are non-blocking execution of concurrent functions multiplexed on OS threads, which synchronize and coordinate using special type called channel. So this definition is a little bit long, but we should look at some example. What is important is to note is that it is based on a communication, and because of it, it is easy to reason about. So let's look at a simple example. This small application have only one function. Its function is to generate unique ID throughout the application, and to use it uses Go routines. We have main function. In the first line of main function, we create a channel, and in this channel, we will transfer an integer. Then we declare and execute an anonymous function. This anonymous function is prefixed with the Go keyword, and it will note to Go that this function must execute in a concurrent fashion. So it will, you can think of it as a thread. So it will spin off in another thread. In it, we initialize the ID to 0 when it starts, and then in an endless loop, we are trying to write to channel, and when write is successful, then we increase this ID variable by 1. In the main thread of execution, we have we read 3 times from this channel, and we will execute this code. Oh, we don't have the internet, right? Sorry. It will write 3 times, 0, 1, and 2 in output, standard output, and I can paste this channel to any part of the application, and I will get the unique ID every time. I don't need to have some other research to handle these IDs, database, etc.
The channels are global?
No. This one is local, but I can paste it as an argument to a function. It can be global. Let's look at some real-world example. So for one of our clients, this client had, excuse me, a particular problem. In production server, it has many log files that are generated. Every log file is zipped on disk in a single file. Every entry is its own file, and they are not very large, but larger. And it has between 4 and 6 millions of these log files generated a month. So a solution was needed to go through all of these log files and delete these files based on business rules. So some log files will be kept for 3 months, some for 6 months, etc. And this was Go was chosen because the client wanted to go this job of traversing the log files to go quickly, but not to overly overly impact on the server to be low. Okay. So this application will spin off fixed numbers of Go routines, and every Go routine will parse a single file and delete it if necessary. Then the main thread will traverse the file system channel all of the files one by one to the waiting coroutines. With this solution, we get a low impact on the server, but fast execution, and we can mix and match that two things. So let's look at the code. We have a type, a file task. It's a structure. It has 3 elements that will be passed around. Then we have 2 global variables. One is a task channel, and in this channel we should transfer a pointer to the file task. Then we have this global variable wait group that will be used to synchronize the execution of the whole program. We will see in practice how it looks. Then in main function, we tell the Go with this strange line to use all the physical processors on the server. Then we initialize the task channel, and then we spin off 1,000 workers. This could be 100, 10, whatever. Go routines are very cheap because they are interpolated on fixed numbers of system threads. When you spin them up, they will wait for work. Then, in the main execution thread, we walk the file system, and on every file, this walk function will call the visit function that we declare later in the code. And at the end of program, we will wait for all the work to complete. So visit function will add a 1 counter to the wait group, and then it will try to write to the task channel this new task it assembled. The worker is at the other end of that channel, or more appropriately 1,000 workers are at the other end of that channel, and they're in endless loop, every one of them, and they're waiting for a task to be assigned, and when it is, they will do their logic, analyze the file and delete them, and when they're done, they will signal to the main program, to the wait group, that they are done with one task. And when all tasks are 0, the program will stop waiting and exit. The last feature I want to talk to you about are interfaces in Go. They are similar to PHP interfaces, but different in one particular way. In Go, interfaces follow this simple paradigm. If something can do this, then it can be done here. And they are implicit. We shall see that on an example. So here, we have again three blocks of code. Okay, the first one and the last one are not mine; they are copied from the standard library. In standard library, there is the definition of the reader interface, and the reader interface have only one method. It's a read method of this signature. I use this reader interface in my program. It's the same program from the last slide of concurrency example. I define the function deletable that receives a reader, and it will output true or false if I can delete this file or not. Then in code, in usage of this function, I open a file and I get a reader, and then I pass that reader to deletable and get the result. But what is important here, and why I'm showing you this, is this. The last block. In this OS package, the open method actually returns a pointer to file, and file is a structure. But this structure implements the reader by having the read method of the same signature. Nowhere in code was noted in explicit way that the file implements a reader. It was dynamic, implicit. This feature of the language makes a supersized application possible, because they can merge in interesting ways, and you don't have to know in advance who will use your interface. You just declare your interfaces, and some other programmer will unexpectedly or expectingly implement them without anywhere explicitly telling you. Okay, so where to start? First, go to tour of the language on this link. It is a wizard. You will be familiar with the syntax of the language. You will learn its features, and the code that you will written makes sense. There are good examples. Then read this how to write Go code. In this article, you will learn how to install it locally and what you need. And the rest of the links you can check out. These slides will be online. In conclusion, Go is exceptionally good at tackling some problems. It works for small tools and big applications. It's fast, it's easy to learn and maintain, and I think of it as a good language to have as a second language, because you can still write your majority of your work in PHP, but you can use Go for that particular use the PHP isn't good at. Please give feedback for this talk on this URL, and I will put slides there. Your question, please.
One second.
Yeah.
No, you can ask. You can have one question.
One question. Okay, one question. No questions, really. Okay.
Can you just mention one nice thing about Go is that when you want to deploy the application, you get a single binary file that you run on the server. You don't need to install any runtime like Ruby or PHP by.
True. Thanks. I forgot about that. It is natural now.
Thank you.
So, thank you.